Good morning, this is Dr. Turner for Integrated Math. Today we're going to be looking at 6.4, which is getting into box plots. Box plots are going to involve having to calculate another type of central tendency. In 6.3 we looked at a central tendency and spread. So we looked at range, which is just simply high minus low. We're going to use those points along with our median to create a box plot, but we're also going to need to look at another example of spread. Specifically, we're going to be looking at what's known as IQR, or interquartile range. You guys have covered this before, but maybe it's been a while, so we'll go ahead and take the time to review it. Let's go ahead and get started here. In the last section, we again talked about central tendency, median, mode, mean, range. For this section, we are going to be focusing on what's known as a 5-number summary. So we do need our median to create this 5-number summary. We do need our high and low, so we do need the range. But now we're going to be introducing a new type of spread, which is known as interquartile range, or IQR. So interquartile range is achieved by taking what's known as the upper quartile and subtracting the lower quartile. So the way of thinking of these is if your median is in the middle, then your quartiles are a quarter of the way through. So the lower quartile is the middle of the lower half, and the upper quartile is the middle of the upper half. The reason that we in math look at IQR as opposed to just range occasionally is because if you have an outlier, which is a point that is really high or really low compared to the rest of your data points, it has a tendency to throw off your range, and it's not an accurate representation of your data set. So interquartile range, or IQR, is sometimes a more accurate representation of how far spread out your numbers are. So to be able to create a box plot, we're going to need to use these 5 points: upper and lower quartile, median, high and low, and then we'll be able to do that. So again, you don't have to have the textbook definition for your notes, as long as you're able to explain it and put it in your own words. That's what I'm more concerned with. So let's go ahead and get started here. Looking at these examples that we used in 6.3, we're going to go ahead and just use the same examples, and we'll keep the extra numbers here just as a reference point here. So here's our 3 examples that we did. We are going to create a box and whisker plot for each of them. Okay. So for the first set of data, I am going to be going from 5 to 29. I already have my median, which is 17. I don't need the mode or the mean, but I do need to find the quartiles. So basically what you do is you take the median, which in this case is 17, and that's going to divide your data set into 2 halves. So I'm drawing a line through 17. That cuts my data set in 2 halves. So on the left I have 5, 9, and 13. On the right I have 21, 25, and 29. So the middle of the left-hand side, 9, that is my lower quartile. It's in the middle of the left-hand side. Okay? And then on the right, 25, that is the middle of the right-hand side, so that is my upper quartile. So when we are drawing a box plot, or a box and whisker plot, we are going to be looking at these 5 numbers: the high and the low point, the median, and then the lower and upper quartile. So I'm going to need to plot those on a number line. So sometimes in an assignment you'll be given the number line already, but not always. Usually you have to kind of do it by yourself. So you need to pick an appropriate scale that's going to work for your number line. So because I have a high of 5 and a high of 29 and a low of 5, I may want to go from 0 to 30. Now, particularly if you're able to do this with a graph paper, you want to make sure that every time you go through and make your number line, that there should be even space between each value. Now you don't have to write in every number if it's implied that each space is even. So for instance here, I have 1, 2, 3 tick marks between 0 and 15. So the implication is that I'm going by 5s. And then 15 to 30, 1, 2, 3. Each tick mark is going by 5s. The most common mistake when constructing box and whisker plots is that students will just write the numbers that they have to chart on the number line. A number line has to be evenly spaced between each dash or each line here. So it doesn't matter what you go by. You can go by 1s, you can go by 5s, you can go by 20s, but it has to be evenly spaced. So first, let's construct the box itself. So the box is going from the lower and upper quartiles. Now here on my number line I went by 5, so it's going to take a little bit of estimation. If this is 5 and this is 10, my lower quartile is at 9 and it goes to 25. So my box would be something like that, going from about 9 to 25. It doesn't have to be perfect, especially if you're doing it by hand, but it needs to be close. Okay? And then you're going to have a line where your median is. So our median is 17, so I'm going to have a line inside at 17. So that is the box. Now, in addition to drawing a box, you also have what are known as whiskers. So for your whiskers, you are going to draw lines going from the box to both your minimum and maximum. Now, some books will use a line for the whiskers. Some books will use a dot instead. It doesn't particularly matter, just a matter of preference. But you're going to put a dot at the minimum point, which in this case is 5, and a dot at the maximum point, which is 29. And then you're going to draw whiskers connecting those endpoints to your box. And that is how you construct a box and whisker plot. Using your 5-number summary, your minimum and maximum, which are your whiskers on the end there. The sides of the box are your lower and upper quartile. And then your median is the line in the middle. And it kind of shows, just like any other graph, it's a visual representation of your data. Specifically here, I can kind of see, well, how far spread out are my data points? Now, we're using simple examples where we have 7 data points or 9 data points. So it's not too bad. But if I had 50 data points, 100 data points, a graph is a more useful tool than looking at just raw data. So that's example 1. Let's keep going. Look at example 2 here. So we already calculated the median as being 18. So I know that's going to be a data point. And then I'm looking at the left-hand side, the right-hand side. On the left, I have 2 numbers in the middle, 10 and 12. And on the right, I have 2 numbers in the middle, 28 and 36. So just like if we had 2 numbers in the middle for the median, think example 3 over here, you're going to take the average of those two. So 10 and 12, that means my lower quartile has to be 11. 28 and 36, that means my upper quartile is 32. And I'm getting those numbers by adding and dividing by 2 or doing the mental math of what number is in the middle. Then, of course, we're going to use our minimum and maximum points. So those are the numbers that I need on my number line. I have a minimum of 10 and a maximum of 40. Again, it's up to you to determine what scale you want to go by. But I think I'm going to just go by 5s again. So here's my number line. Let's say I'm going from 0 to 40. So try to be as accurate as possible. There's 20 in the middle. And then each of these, therefore, is going to represent 5 again. All right, trying to keep that space even between. So I have my box. My box is going to go from 11 to 32. So again, if you have the means, you want to be as accurate as possible. But here, so I have a line at 11, and that's going to stretch down to 32. Adjust this a little bit, say about there. Again, it doesn't have to be perfect, but it should be close, right? So there's my box going from 11 to 32. My median is 18, so I need a line at 18. And then I have my whiskers. Whiskers going from 10 to the outside, and then 40 to the outside. And that is my box and whisker plot. 5-number summary, I'm using my minimum and maximum for the endpoints. The outsides of the box are my lower and upper quartiles, 11 and 32. And then I have a line in the middle, which represents my median. All right, and let's do our last example. Okay, so again, for my median, I had 15 and 20, which the 15 and 20 were in the middle, which means to find the median, I had to add them and then divide by 2, which gave me 17.5. So then I need to find the upper and lower quartiles. So you have a minimum of 5. You have a maximum of 25. You have a median of 17.5. And then you're finding your upper and lower quartiles. Your lower quartile, left-hand side, the middle would be 10. Your upper quartile, you have 25. Okay, so taking these numbers, we're going to put them above a number line. I'm going from 5 to 25, so again, I'm just going to stick with 5. That seems to be working. On my number line, I'm going to go from 0 to 25, so 0, 5, 10, 15, 20, 25. My box is going from 10 to 25, so I can do that above the number line there. Okay. And then I have whiskers at 5 and 25. My median's at 17.5, and then I'm going to connect the whiskers. Now, depending on the data set, like in this example, it looks a little funky because that whisker isn't extending past the box. It is possible, depending on the data set, that your values could overlap. So you might have a median that's the same as a quartile. You might have a minimum that's the same as a quartile. You might have a maximum that's the same as a quartile, and that's okay. It just really depends on this data set that you're looking at. But that's it for 6.4. If you have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.